Hello everyone, welcome back to Structure. Today we have to design water supply reservoir by using Graitec event design. Now let's start. We input the name is water supply reservoir or sea water. We use the rainfall concrete. Okay. Now click on home menu and display the work plan, and you have to view on the front view. You can draw a line from AutoCAD. After that you can import to the Graitec file, import a DES file, and you can select for the DES file from the AutoCAD and import direct to the AutoCAD. But in this case we have to complete the link by using Graitec, and we have to draw a line. Now start from here. Now start from this line. Okay. This line, and we start to draw using from line. Okay, this one, this one, this one, this one, enter. And after you complete model one side, we have to click on this line, and you select on extrude of an element. And now you have to click on the original location want to rotate, and you have to input the angle calculator. The angle of the one called is 360 degree. So you have to divide it to what segment you want. If you want to 10 segment, you can apply it 10. You see here the angle is 36. Now we input the angle 36 and the number is 10. And the thickness and the concrete you can import from the library. Click on import. Okay. You can change to the C30. Why we use C30 and not use 25? Because durability of the concrete structure you have to include for the reinforcement cover, and with the reinforcement with the concrete strength. So you have to check for your cloud exposure. Now the type is cell, and the thickness we use 25. Okay, and you can preview. See here, you can preview. Or other way you can change your original. If you don't want to use this original, you can click on the original. Okay, now let's start. We have to show you when I click and extend. Now let's start again and do the same, and you can change your original to the location example, and you can click on the object. Okay, you have to click on object first and extrude and preview. You see here This is the preview, not the generated structure. After you apply, this structure will be complete. Now you can check for this line. You have to correct it. Okay. Now you do the same and click extrude, apply. You see here, and you can modify your model. If you don't want to use this segment, you can change your model. Example, I want to move my model to higher. You can click and now let's move. Click on object and click on move. This is forward. Click on object, move. Now I want to move it to Z direction, or you can click and click other portion or other one you can input directly. Now I want to move to the more 6 meter. You can preview. You see here your model is in the location. Now apply or move. After that you can click again and your portion. I just want to show you how to model and how to modify your structure in the case. So you have to click on this again and apply. Okay. So here it is your complete 3D model. You can escape and turn off plan view. You can delete line if you don't want to use it anymore. And after that, you can check your element is around 110 flat was generated. You can hide on flat and you can double click on it directly, or you can double click on the folder. Okay. If you don't want to show about the local axis, you can now we have to we can hide the local axis by display and change to the none. Now we have to seal our model. Okay. And you can click on zoom and double click on texture again. Okay. Double click to hide and to display. This is complete for our modeling. Now we have to assign for the support. Click on the shell, right click, support, rigid, and we have to apply the restraint effect. And you see here we have to apply OK. This one for our support. We can create other structure, other substructure by click escape. and you can take call it support and click shift and click again, move to the support, close, and you can check for the concrete is not correct. You can check and modify it and check for the thickness is correct. And for the cover is correct, really dry. And for the class exposure HC3 moderate humidity, wet and dry, and you can click on your class exposure wet, really dry, HC2. You can classify different class exposure. Example, if you want, you can select it for the HC0, and for the upper cell you can click it HC2. Now we do it the same by right click, click on the cell, and you can choose the HC2 and enter. And for the column and for the wall, we have to check for the stress. Should we include all, and for the real calculation deflection we also active, and we active for the correction of crack. Okay, now we have to click on the upper cell, check the class exposure is correct, and cover we have to change to 4.5. Or you can take it 5, because this cover take from the top cell to the centroid of the bar, so you can round it to 5. Okay, 5 correct. We use the correction of crack, click on tick, and also calculate for the deflection. And now we just complete from the modeling, assign, modify the thickness, and now you have to change for the concrete, because our design lifetime and durability, we have to use high concrete and use the suitable concrete cover for durability. And the thickness you can correct it later. Okay, now you see here that we have support, and we have complete the design, the modeling. So you have to apply load. In the case, you click on the load, new, the load in the service, and can create for the light load if you have another light load on this structure. But now we have to focus about the wind load, and also light load we can take the liquid as light load, so you can create another light load, and one is for the wind load. Okay, now let's start. We have to apply the wind load on the structure, and also apply the apply the liquid pressure on the top shell. Now we click on the light load and click. You have to click all the upper shell. Okay, right click, you can click on the pressure on selection. You check here, this is the lower from the ground to this position is 13 meter, and the upper is 22, at the top 22, and the vertical axis is set. And the liquid density you can use 1000 per cubic meter, and for the pressure, direction of pressure is to the external, not internal, and the local load case we apply for the light load, and you can select OK. And now we have to check about the load direction is correct or not. You have to check about your again I click on the light load, and you have to output the local axis. Now you have to change all local axis. You see here the local axis is direction to the inside. You can change what the one you can manually change the direction or load in here, but in the case I don't want to use this method. You have to keep and to try automatically by software. Now I click on this load again and click cease, click and delete it, or you can use the minus sign in here. And you see here the direction of load is correct. Use the auto scale. Now the direction of load is applied to outside direction is correct with our concept. Okay. And you want to check about the location to make sure it's correct, and you can click on it. Now I want to hide the object. Okay, you can check. You see here the direction is the output. You can change it manually. Okay, now everything is complete and correct. You can check for the apply pressure. Click. You see here the direction perpendicular to the shell. And now we have to apply for another pressure for the light load. This one for the pressure. You have another pressure and the vertical direction, the direction to the downward. We have the lateral pressure, and the other one pressure is direction in gravity load. And now we can click on this load, and the location is correct. Now we have to apply for another location by high or load in the light load. Okay, again we select on the cell. Okay, on the cell. Click on this one, on this one. You have to make sure your cell is clicked. Okay. And you have to apply for the vertical pressure, and click on the pressure on selection. You see here the direction is set, and want the pressure direction is internal. You can click OK. you see the direction of pressure. Now we have to change it. Click, click. We have to change the direction to minor. Okay. And the direction, you can click on the global axis. It's correct. It's correct right now. That we just complete load assigned. Okay. You see our structure, we have the pressure in the sideway, perpendicular to the cell. Okay, we call it lateral pressure. Lateral pressure. And this load is applied full when the liquid contact with the oscillating. The direction is perpendicular. And you has another load in the gravity load, direction in the gravity load. This one is equal to height multiplied with the density of the liquid. Density of liquid. Load in this direction. So it affects on the this direction. We divide in the different area. Okay, now we divide it into, and this direction no effect from the pressure at the upper direction. Upper direction, we classify it the upper direction. No effect from the pressure, but in this side has another effect from the pressure. Okay, now just to explain you why we apply the pressure, and then we continue to apply another pressure at the cell at the hard cell below. We call dirigent. You see, the lateral pressure is applied full when the liquid contact with the OC cell. But for other pressure is the direction with the gravitational load. Direction to gravity, and apply with the contact the load multiplied with density of the liquid in this direction. Now if you continue, it continue and continue it. Okay, now just to explain you to avoid any conflict about how to apply load. Sometimes software cannot generate the full load, so you have to add another load, or you have to manipulate it, or you have to correct it direction, because your local RC is not the same. So you have to correct your local RC before you can assign load correctly. but in the case because but in the case we do not change any direction of the locality, so we have to change directly the load direction. Okay, now after complete for the line load, or we can call it for the water, you can change it water pressure. Okay, this one you can call it service. Okay, and seal. And after you complete these two type of load, you can turn it off by clicking on the load, by clicking on the line load, and we can take the quality off, and double click on the structure again, or you can shift click. Okay, select all load, select all cell, right click and click on the reload. Now we have to assign this structure to the selected load. Now we have to find where it is selected. Okay, this one is selected. Select load area on selection. Click on it, and you see here 110 plate wind wall load selection earn. Okay, now you have to check this is for the wind wall auto generated for the selected cell. You can cut it and create another substructure by Graitec and call it wind wall. Okay, and after that you have to pass it. Now you can turn off wind wall. After you assign wind wall, you can apply the wind load automatically, and you check for the wind load, and we have to apply the split area when your structure is taller and taller. The area and the load it will be split depend on the height and the ratio with the width of the building or width of the structure. So now we have to split when it's applied from here to here. The another different load ratio when the height is increase. So we have to check another factor. No, incorrect. And the wind speed, the basic speed, you can check and click it direct on the map. Now we apply it 22 meters per square meter for the interval period 50 years. You see here the pressure is 0.3 kilonewton per square meter, and the bidding height, you have to apply the bidding height. Bidding height is 22. Is the our structure height. Entrance category, you can select for the rural, urban, or for the city. I click it for the rural. And wind force we apply both. Topography we use the default. Okay, now we just complete how to apply the wind load. I want to seal it again. Press Ctrl S key, and you can click and delete this default wind load, and we have to generate automatic generation. Click on this icon and waiting the software generating the wind load. Now click on the right click and select on the auto load auto scale. You have to check about the load direction to make sure the load direction is correct. Wind load is applied to the cell. The direction is correct. Now you see here the correction applied is correct. You can turn off and show it 1K by 1K. Hold on C key and click, double click, and you can check one locus is correct or not. Okay, this direction is applied into the wall is correct. Okay, apply into the wall is correct. And the direction is applied outside. Okay, is correct. And you can check for the other option. Okay, this direction is the windward and this direction is the leeward. Okay, it's correct. Now we have to turn off the wind load. Okay, you have to check it to make sure your structure is correctly, you apply load correctly. Now I want to turn it off. Double click on it. Double click on it, and after that you have to apply load combination property and click on the simplify. We want to generate also for the equilibrium load combination, and you can check on the generation. Click on the generation. You see here the load start from the 101 to the 200 for the serviceability, and the one for the ultimate equilibrium. This is for the coefficient for the dead load and for the light load and for the wind load. And you can check for the concrete. You see here the surface and for the water pressure, and this one for the wind. Okay, correct. Press OK. Let's zoom there again. Now you can check for the on envelope, create family or envelope. Click on it again, right click property, and if you want to envelope for the displacement, you can click the displacement and check for the planar element, and you can check for the min. Now in the case I want to envelope for the force only, planar element, and you check for the min, and you can click on the locus. Okay, apply, close, and you can create for nodal analysis for the dynamic, or you can generate for the localized buckling, nonlinear analysis, push over for the dynamic analysis, or for the seismic analysis. You can check the option. Now I want to click on the generalized buckling. I want to analyze for the buckling, and you can select for the load case relevant with your design project or the critical load case. If you don't want to run slowly when you the computer, so you can reduce the time by click productivity and click only for the load combination that you think it the critical load combination. This one is for the surface include the water pressure and you can click for other, include for the win load. So the win load, there are a lot of win load. You can issue it by using only one or two load direction. Now we have to include this load. You can minimize the load combination. Now we have to include all reload. Okay. You see here for the general line buckling, you see here the general line buckling, and the number is 5, and see for the load after complete generated for the buckling, you can click on it, as you see here, backlink, and throw the number is the reference. You see here the reference, you can check the reference combo. Okay, after you complete generate general line backlink, you can include for the load. Right click and you can click for the model analysis. Again, and click on the model, and you see here the name is the mode. The type we use the enchain vector. You can use on the load depend on the res vector. Now we use the enchain vector, and the mathematics is the lambda number mode. You can increase it. Indicate I don't want to use only one. I can we you call to analyze. You can make this number at least 3 or 4, but the first mode is very important. It is the possibility that can occur in the first mode. For the 3, 4, 5 and 6 mode, it's really happened for the real in the real life of the structure. So we have to increase it to the 3. Now I can analyze for the 3 mode. You can, okay, the definition point mass 7 is correct. If you want to apply for seismic, you can include the damping for the seismic and auto calculate. Click the option, import damping in default. You can change 5%. Mass sensitivity indicate you can apply mass sensitivity because our structure is symmetry. We know other mass sensitivity. And okay, now let's use Control S again. Control S again, and we have continue to analysis. Click the OC element design. You can calculate for the pushover calculation. But now we focus only for the OC design without any pushover calculation. Pushover is for the existing structure for calculate with the dynamic. Okay, waiting software complete calculation calculating. You can enjoy your time with the breakfast or with the coffee time, and let software run. When you generate more load case, so your computer will need more time to analyze, to process that expression. There are a lot of expression when you increase the load combination. So in some case, if your computer is a low RAM, you can minimize the load combination by you only 1, 2, 3 or 10 load combination is enough. Do not generate automatically by the software. You can manually input the load cache and input the load combination manually, or you can delete some load combination automatically output from the software and keep only for the 3 or 10 load combination that relevant with the structure and you have to analyze which load combination is critical for your structure, so you just keep that load combination. You see here, the program has detected a certain number of warnings that can give you. Okay, this is a warning about the load super report, because it overlaps when you apply it the same for the pressure at the lateral pressure and the ground in the gravity pressure. So it is for the alert or the load. You see here for the reload, that is not a concern because it is compiled with our concept. Now you have to check for the info. You can check for this load case. This will come back to the model. You see here my PC now slow because we analyze more options and we use a lot of load combination. It made my PC slow. So it's not necessary. You can issue the load combination and issue the option for analyzing the structure. You can analyze it one by one. After you complete, you can do another option. After complete analysis and design, you have to seal it again. Click on seals. You see here at the error there are 69 error, so we have to check what is error. Flat N01 regularly concrete cover. So we have to come back to model and via if flat N01 we can select by criteria and click on the flat one. Okay, this one you see here, flat N01, the thickness is 25 centimeter, and concrete cover E3 is not correct with the exposure class, so you can increase the concrete cover. Okay, you can increase to 4.5 or 5 centimeter, so this area will be correct. And another one, flat and 01, the lower reinforcement are compressed. So what does it mean? Your section will be designed into two different categories. First one is for the singly reinforcement, and the second for the doubly reinforcement. So also a compression member also require when the section it cannot receive for the tension reinforcement, need another compression to calculate in this section to increase the bending capacity, to increase the capacity of the section. So to avoid this error, you can also increase the section of the shell. You see here is the same, is the same for the wall column. I call it wall column. So for the wall column, you can fix this error by increase the concrete cover, and in the case you should increase the thickness for the wall and for the upper shell element, you have to increase it, and so this area will be correct. Okay, for two flat and 2 another is the mistake for the lower reinforcement are compressed. So after you increase the section, this folding will be disappear. Okay, 69, but you can summarize it's around 3 or 4 mistake or 4 error. So you just correct that the section or the section, this area will be fixed. Okay, now let's start to the analysis again. Open existing model. We have to check about displacement. Now we check about that. You see here there are a lot of core combination, so your PC will be run slower, much more time to complete this analysis. Now check for the maximum deflection in the survey is 0.43. Okay, when you apply for the water pressure is 1.73, and when you apply for the wind, you see here for the wind and the direction is almost the same. Okay, and you can check for the circuit. Okay, this one for service 7 plus with the water pressure is 2.54. You see here 2.54 the displacement, and you can check for other combination is 2.54. Okay, and as you can rotate it and can do animation. Okay, you see about the displacement is going down in the gravity load direction, in the gravity. See here, so the displacement is this position is around 256. So in this case you have to add a beam at the top, and you can increase your section at the bottom. Okay, at the bottom of the bottom cell you can increase it, or you can add its tri beam to reinforce or to improve your diffraction. You can add a beam, another beam. Okay, now you can check about the mode. This is for the mode. We consider about 3 mode. You see here you can process. Mode 1, mode 2, see here, mode 2 wind load, mode 1 for the gravity load service, and mode 3 you can check about the mode. Okay, see here in the direction. So we had to add another restraint in the location. You can add under cell or under flat to restrain at the middle span, middle of the wall. Okay, vertical wall. And for the top of wall you can add another beam, and you can add another beam to improve the diffraction. You see here the diffraction in the area is too much. And now you can check for the buckling. Let's check in the document. I show it again. You see here for the mode 2 the frequency is 1.81. Yeah, suitable for the load 2, mode 2 and mode 1 is 1.76 is suitable for the frequency. And now let's start generate a report. We have to check to delete all in document, table, results, model analysis. You can check for the characteristic mode and the model vector. You can click, and for the buckling can click, and for the model we have another character view of mode. Okay, generate. Now you see here for the model value, this is for the frequency in X 1.79, 1.71 and 4.56 for the model, and this one for the critical load factor. You see here the critical load factor for load case that we assign from the 37 to the 69, and the load control in mode 1 magnificator is 47.59. What does it mean? So it this critical load factor in our structure can resist the applied load. When you multiply the applied load with the application vector, it is equal to the buckling load. Okay, now you can check. Okay, now we have to continue. to check for another result. Click for the reinforcement, and for reinforcement A, HB at the bottom. You see here you need a lot of reinforcement in the location. It's around 46820.96. calculator Excel. Now I have to take my Excel, my spreadsheet. You see here about our reinforcement is around 468.2 centimeter square centimeter. So now I put the value is 10, 20 or 10 is 10 10 dB 10 dB 16. You got only 20 square centimeter, but your requirement is 469 centimeter, 468 square centimeter is over, so you have to square centimeter. You see here about the reinforcement need in the HB in the bottom reinforcement. The local axis we go invert direction, so the bottom is the outside, okay, the outside area, or the vertical wall, okay, the outside, okay. So in this direction you need HB is too much, so you have to check for the issue. You have to increase for the add another shell in the top and add another beam, and you can check it again, and it B in B direction. You see here it here natural rebar either connect between the upper and lower shell element here at the top. See here at the top, is see here for the rebar, okay, for the rebar. You can check for the backlink. You can check for the maximum slenderness. Sorry, we check for the shell element. No, you can check for the design fault. You can check for the VU, the value of VU. You can check for the H in bottom in each direction. Or you can check for the capacity check. you can check for the concrete stress. You can check for design capacity. You can check for concrete deflection. Here for the total deflection. Okay, it's around 2.72. So what does it mean? It deflect in the gravity direction. Now you can select only this element and select on the filter. Okay, now come scan to result and check for the reinforcement again. Okay, now let's check for another parameter before we come back and correct it again. Result. Now I have to seal it to another model. Seal as the division we want. Seal. Okay, after we seal, now we have to correct the issue. Now we have to display it all. You can display it all. Okay, display it all. And come back to our model, and we see here about undership buckling and about the mode, our frequency. So in the